Okay guys, now look at these two examples. The I square and 1 over I over 20. Let's look at this first one. Alright, if you remember this one, the formula that you're going to use to solve this one is going to be n plus 1 to n plus 1 divided by 6. And actually that's what they did here when you look at how they solve it. There goes the C. There is I squared is going to be n, which is 20, n plus 1, which is 20 plus 1 is 21, times 2n plus 1, which is 2 times 20 plus 1, 2 times 20 is 40, plus 1 is 41, and all of them divided by 6. And if you use your calculator and do this, probably you will get 2,870. Now look at the second one. The second one, you also will get I squared. Here it is. But this 20 squared, which is going to be 400, you can take it outside because it's a constant, right? Take it outside the summation, and then you do the I squared, which is going to be again 20, which is n plus 1, which is 20 plus 1, 21, times 2n plus 1, which is going to be 2 times 20 plus 1, 41. All then divided by 6, and if you do this probably you will get the answer here, 7.175. Yeah, try this one. This is the same notation and procedure we're doing all around. Now let's look at these examples. These are a little bit more complicated. This one says, okay, computing the sums of function values, and it says here the sum of the values of f of x, which is equal to x squared plus 3, evaluated from for x that it goes from 0.1, 0.2, 0.3 all the way up to 0.10. Now you can see this one. They want to do you the sums of this function here. But look at these increments. It goes from 0.1, 0.2, 0.3, 0.4, 0.5. If you look, this increment is always changing 0.1 until you reach 0.10. And it's telling you also that it has only 10 possible values because it goes from 0.1, 0.2, 0.3, 0.4, 0.5. We can try all of them here. It will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So you have 10 values here. So this one is telling you that n is equal to 10. Oh, good. Good about that. Good. For I, that it goes from 1, 2, 3, 4, 5, all the way up to 10. N is equal to 10. So you can name this function, or at least that increment, we can name it as I, or AI, which is equal to f and the function of x, and you can see x is changing 0.1 every time, so it's going to be 0.1i, and if you evaluate this inside the function, this is going to be what? 0.1i squared plus 3. That's it. So when you do here the summation, let me show you what they did here. Not precisely what they're doing. They're calling this, let's say the first one will be for f1, which is actually 0.1 squared plus 3, and the next one a2, which is going to be 0.2 f of 0.2, which is 0.2 squared plus 3, and so on and so forth. So the equations start looking like this. And when you substitute these into the equation, right, it's always going to be 0.1 is 0.1 squared plus 3, where I goes from 1 to 10. And now if you put these things into the equation, the one that it says summation of I, that it goes from 1 to, and actually since this square, it will be I squared to n. The equation we'll be using is going to be this one, n plus 1 to n plus 1 divided by 6, right? Good. And so in this case, this equation, this formula is going to look something like this. The summation that it goes from I equal to 1 to 10 of, here we got, it's going to be 0.1 I squared, and let's put a bracket here because we have to add plus 3. This is actually the equation we'll be using. And since we have here two terms, let's do it. It's going to do it individually. It's going to be what? The summation that it goes from I equal to 1 to 10 of 0.1 I squared plus the summation that it goes from I equal to 1 to 10 of 3. Now we know this one's going to be 30, but what about this one here? Let us write it here so you can see more or less where we're going with this one. It's going to be I equal to 1 to 10 of what? Well, 0.1 squared is actually 0.01, and I squared is going to be times, sorry about that, I square, and in this case plus, well, 30, right, because we already had that one. So this one we can take the 0.01 outside, and then we do the summation of the numbers going from I equal to 1 to 10 of I squared, which in this case, oh, plus 30, I'll forget this one, which in this case is going to be 0.01 times, okay, n, right? N in this case, using the formula, is going to be 10. 10 plus 1 is 11, times 2 times 10, which is 20 plus 1 is 21, all of them divided by 6, plus 30. And if you do this, the answer is going to be 33.85. And if you look at the next slide, it's actually how they solve it. Let's see. Here it is, right? They put the 0.1 square outside, which is going to be 0.01, and then they did I square, and 3 times 10 is going to be 30. That's why they got that 30 here, right? Everybody got to see that. Now this one is going to be what? 10. 10 plus 1, 11. 2 10 plus 1, 21. Divided by 6 times 0.01 and plus 30, right? Because we have the 30 here. So we got 3.85 plus 30 is 33.85. Okay, guys, I hope this helped a little bit. Try to look at those, the book that I give you, the Marsden and Weinstein book, unless you have your own textbook, and work a little bit with these problems and the one from the homework. Okay, see you guys. Take care.